Assalamu alaikum. Hello, grade 5. Today we are going to continue our math lessons, and today's lesson is symmetrical figure and the axis of symmetry. First, can you look at those figures? In the given figures, we can see a line dividing each figure into two identical parts. Can you see this arrow? It has an identical part to what we have on the top directly on the bottom. And the same thing for the little h and for this rectangle, for the dividing sign, the rhombus, even the butterfly. What you have on the right, you can see it on the left. Letter T. And even this mask, what you can see on the right, you can see it identical on the left. Well, the line is known here as the axis of symmetry. Remember this word? Axis of symmetry? What is the axis of symmetry? The axis of symmetry is a straight line dividing the figure into two identical parts, which means if a paper is folded on the axis of symmetry, the two halves will coincide on each other, which means if we folded this paper, if we imagine that we have a paper here and we fold it, we can see the two parts are very congruent to each other and they are on each other, coincide on each other. Well, does this mean all figures have axis of symmetry? Well, we have some symmetrical figures and non-symmetrical figures. How can I know that the shape I have is symmetrical or not? Can you see the straight line L? Well, this straight line L is considered to be an axis of symmetry for a figure if every point in the figure has an identical point on the same figure with respect to the line L. What does it mean? It means every point in this shape is supposed to find another one like it on the other side of the line. How? Let's see it very carefully. If we said maybe I can take this point here. It is on the right of the line. Does it have an identical point on the left? Yes. Point here and point here. So we can say that L is an axis of symmetry. But only for one point? No, for all the points. Every point on the right supposed to find another one on the left. Every point on the right supposed to find an identical one on the left. What about the number of axes of symmetry? How many axes of symmetry can I draw? Well, let's remember together what we learned in grade 4. Do you remember these shapes? A square. How many axes of symmetry does it have? 4. What about the equilateral triangle? 3. A rhombus? 2. What about the parallelogram? Can you draw any axis of symmetry here? Maybe if we try to make it in the middle like this one, maybe? Nope, it's not. Or maybe like this one? No, it is not. So it has no axis of symmetry, which means the number of axes of symmetry is 0 here. Well, let's remember more about the number of axes of symmetry in some geometrical figures. The scalene triangle has no axis of symmetry, so the number is 0. The parallelogram, also 0 axis of symmetry, and trapezium or trapezoid has 0 axis of symmetry. But the isosceles triangle and the isosceles trapezium has 1 axis of symmetry, the rhombus has 2, and the rectangle has 2 axes of symmetry. Equilateral triangle has 3 axes of symmetry, and the square has 4 axes of symmetry. I know that you are saying we learned this before in grade 4, why we are saying it again? The axis of symmetry is going to help us in a new topic. This topic is called geometric transformations. What is the geometric transformation? Geometric transformation is a change in the position of the figure, which means it makes the figure move from one place to another. I'm taking a shape and moving it. In other words, we can say that geometric transformation transforms every point A in the plane to another point A dash in the same plane. Well, we still can't understand it. We need to see it. For example, this man. The original place is here, the horizontal one. He is sleeping here. But Now he is like this. He is moving. The same person, but he is moving. Or maybe like this one. The mountain. I can see two mountains here. One is the original one, and the other is its image on the lake. Or maybe those planes. It's moving on the sky. It's not in one place. So this means we can change the place or the position of any figure by three basic geometric transformations. The first one is reflection. What is the meaning of the reflection? In the reflection, we flip the shape, which means it's like the mirror. If you are standing on the mirror, you are going to see the image of your point exactly like that. And the image of this point here and the image of the far point is going to be far from the mirror itself. So here, in the reflection, we flip the shape to reflect a figure across a line, like a mirror. Second one is translation. Translation is to slide the figure. Here is the original figure and you just moving it from one place to another in the same direction. We are not moving anything here. I am just changing its place from here to here. Or moving the figure in certain direction along a line. The third one is the rotation. What is the rotation? In the rotation, we turn the shape. Can you see it here? Here is the original one. It is totally different here. In the same length, the same sides, we are not changing this part. We are just turning the shape. It means turning the figure around a point with a certain angle. So, the three basic geometric transformations that we have are reflection, which means to flip the figure, translation, which means to slide the figure, and the rotation is to turn the figure. To understand it more, we are going to solve together some exercise. Describe the type of the geometric transformation, reflection, translation, or even rotation. How do you know it? Can you see this figure? It is the same or not here? The same figure. All what you did is just to slide. I didn't change anything. I just slide it from here to here. So it is translation. What about this one? What is happening here? Well, first, the right angle was here, but it became on the top, so something is turning the shape. We just turn the figure here, which means we are having rotation. What about the letter F here? The same or not? It is the same. No change in the directions. No turn. So it's not rotation. I'm just moving from here to here. I am making a slide. So it has translation. What about this figure here? The parallelogram. First it was like this one, then it became from here, so something changing. We have here a turn. We turn it, so rotation. What about this shape? It is not slide. There is something different, and it's also not a rotation. I'm not turning. But if I put a line here, maybe it's going to be like a mirror. So when you have it like a mirror, we are making flip. We are flipping the shape, which means reflection. What about this one? It's also like we have a line in the middle. It has another reflection. Letter H. Something is changing. It does not slide. Well, it's supposed to be turn, so it has rotation. And the last one here is the same arrow in the same direction, but from here to here, so it has translation. Like this, we have finished our lesson for today. I hope you are enjoying our videos. Thanks for watching grade 5. See you next time.